Yes, so Joanna, am I audible?
Yes, sir.
So, what was the last topic that you were doing in your school syllabus? Joanna, the chapter
Sir,
that you were doing in your school.
we took second lesson.
Second chapter.
Yeah. Yeah.
You're doing capacitors or current electricity?
Yes, sir.
Which one?
Yes, second lesson. That's what we took.
Second lesson. What's the name of the chapter? It's second unit or second chapter of NCRT?
Second chapter.
So you were doing potential and capacitance.
Yes, sir.
Okay. Oh, I took a class of your school. In your school, I've taken a class of your school, and you people were doing current electricity at that time.
Yeah, that time we were doing current electricity.
Okay. You were doing current electricity, huh?
Yes.
So what you want me to start from? You want me to start from right from chapter number 1?
Yeah, electrostatics.
Electrostatics. Okay. Start with electrostatics. So when your school will reopen?
They say September 2.
September 2.
Yes, sir.
Giovanna, I'm just waiting for a few more students. Let's wait for 2 or 3 more minutes and then we will continue.
Okay, sir.
Just waiting for a few more. Okay, let's start with unit number 1.
Okay, sir.
So that's electrostatics. The weightage of electrostatics is around 8 marks in CBSE. Now this is being divided into 2 chapters further. It's chapter number 1 is electric charge and field. It's basically chapter number 1 of NCERT. The second is electric potential and capacitance. Electric potential and capacitance. Okay, what books you people use for your boards exams?
For gates, I'm using exam idea.
Exam idea, okay. For the practice of numericals, right?
Yes. Usually I use this New Jyoti guide, but then this year I couldn't go for vacation, so I didn't get it.
Okay. So first of all, you will use NCERT. That's your textbook. Each and every line of NCERT is a part of your syllabus. Whether that part is the normal exercise or the additional one, skip even a single line of NCERT. NCERT is your syllabus. Then along with NCERT, for numericals, for theory portion, my class notes are more than enough. Each and every question that you will get in your school exams or your boards exams, each and every theoretical question you will get from class notes. For numericals, I will regularly sending you assignments for numericals. So this is class notes and enough for theory. And for numerical portion, you can rely on these assignments.
Okay, sir.
So after this, if you have left with some time, you can use any book, any references you want, but you have to follow at least these 3 things thoroughly. NCERT, class notes, assignments, and along with this, tests. There may be few questions that I won't cover in assignments or class notes, but those questions you can get in your tests. So these tests are equally important. These are the references we are using. So in this particular batch, I would be targeting your school exams and CBSE only. If you want to do SAT or any other entrance exams along with 12, you have to inform me. Right now, I'm just planning the whole syllabus according to your school exams and your boards exams. That's just note it down, Jubena. Let's start with the chapter number 1.
Okay, sir.
Yes, Jubena, shall I rub it?
Okay, done, sir.
So before starting this syllabus, I will need some portions of class 11. Although we have covered all of them during that 7-hour course, but still I will need these topics. The first one is vectors. The second one is differentiation. And the third one is integration. You will need these three topics to solve numericals of NCERT and relate it to your board's exams. So, Jimena, you are comfortable with all these three topics? Vectors,
Yes, sir. I'm comfortable.
So let's start with chapter number 1. That's electric charge. This electric charge in field starts with the concept of electric charge. So how will you define electric charge? What is electric charge, Jabena?
Positive and negative.
Yeah, positive and negative are two types of electric charges, right? But what is electric charge? There are type of charges, right? The
Yes,
charge
sir.
on electron is negative, on proton is positive. But I'm asking, what is electric charge exactly? So that's a tricky question. See, to define electric charge, you can write this as electric charge is an intrinsic property of matter. Intrinsic property of matter, which give rise to electric force, electric field, electric potential energy. So the origin of all electrical properties of a system is due to electric charge, electric potential energy. So that's electric charge. So what is intrinsic property? See, when we say use this word intrinsic in physics, intrinsic means something which is most fundamental. It's so fundamental that you can't define this particular quantity in terms of any other quantity. It's like if we talk about a language, you can say that letters in those language are intrinsic. You can divide your sentences in words, you can divide your words in letters, but when you come to letters, those letters are intrinsic, they are most fundamental. Those letters can't be further can't be further explained. Like I'm saying A, define A, you can't define A, you will say just A is an intrinsic letter. So intrinsic word in physics stands for quantities which are so fundamental that you can't define them further. So if I'm saying that something is matter, whatever you have around you, you can divide those things into two categories. They are either matter or they are waves. If you say this pen is a matter. If it is matter, then it should have matter, or I should say, if it is a particle, if this pen is a particle, then it should have some properties, some intrinsic properties. For this pen to be a particle, Jumana, can you just list few properties that this pen can have if it is a particle?
Components.
No, not components. Like properties, it's like mass.
Okay. Space.
Occupy space? No. Not all particles will occupy space. It's mass. Next is electric charge. And the next one is spin.
So all particles has electric charge.
Now, if you're saying that something is particle, then it can have it should have at least one property out of these two. If you're saying something is a particle, then it should either have mass, or it can have electric charge, or it can have spin, or it can have all three properties. But it should at least have one of them. If you're saying something is particle, so particle will either have mass, or electric charge, or a spin, or even it is possible that a particle have all three properties. By spin, I mean that intrinsic spin that you must have done in chemistry in your class 11. The spin of electron was plus minus half.
Yeah.
Remember this thing? This was in chapter number 1, atomic structure in chemistry. Quantum numbers, spin quantum number. When I'm writing spin, this is basically spin quantum number. There were quantum numbers in chemistry, na, like principal quantum number.
Yes, 0, 1, 2.
Yeah. So that's the spin quantum number. So if you're saying something is particle, if it is particle, then it can have mass, it can have electric charge, or it can have spin quantum number. Particle can have at least one property out of these.
Okay.
So can you mention a particle which is massless?
Air.
Air. No, air have mass, like oxygen have atomic mass. Air is basically a mixture of gases. No? The major component of this air is oxygen. Oxygen have atomic mass. Any other particle which is massless, absolutely massless. So Jivana, have you heard about photon?
Yes.
What are photons?
Positive charged.
No.
But
Yeah, I'm not writing proton. It's not proton. I'm writing photon.
no, sir, I don't know.
I'm not writing proton. I'm writing photon. Photon is
I-
basically, do you remember Planck's quantum theory in chemistry? Class 11.
Yes.
So when you say radiation, if you have a source of light, then radiation, this source of light will emit some radiation.
Yes, sir.
This radiation, you can consider this radiation as a wave, or you can even consider this radiation as a particle. When you consider this radiation as a particle, then it will consist of particles which are known as photons. If you consider your radiation as a particle, then this radiation will consist of photons. Jibana, each and every topic that I'm discussing in class is directly or indirectly related to your syllabus. Even
Okay,
if
sir.
I'm writing something is note, this is related to some particular numerical of NCERT. Okay. So basically the structure of NCERT is NCERT never write all things in theory. It gives a measure of data, measure of parts in theory, and a minor portion of information are hidden in numerical. So whenever I write notes, basically I'm considering that portion of NCERT which is hidden in numericals.
Okay, sir.
So photons, when you consider your radiation as particle, when you say that radiation consists of particles, those particles are known as photons. If the light rays coming from the bulb, you can consider them as a wave, or you can even consider them as a stream of particles which are moving with a very high speed, which is 3 into 10 raised power 8 meters. Photons, which are particles of light, they are massless. The rest mass of photon is zero. Mass of photon. They are neutral. Like charge on photon is zero. This survive only due to spin. The spin of photon is plus one. Those photons survive just due to their spin. For something to be a particle, it should have at least one of these quantities. And all these quantities are intrinsic. If I say define mass, you can't define mass. In some books, there's some misconception. Some authors write that mass is the amount of matter in a body. That amount of matter is basically measured in mole, not in gram. That amount of matter is the definition of mole. It's not a definition of mass. The definition of mass is it's an intrinsic property of matter. So if you're saying something is particle, then that particle should have at least one of these three quantities. It will either have mass, it will either have electric charge, or it will have spin. It can have all of them, like electron. Electron have mass as well as charge as well as spin. But this photon is a special candidate. The mass of the photon is zero, it's a massless, it's a chargeless, a neutral quantity, it just survived due to spin. So, Giovanna, this intrinsic is clear?
Yes, sir.
Intrinsic property which give rise to electric force, electric field, and electric potential energy. Now, in nature, you came across two types of charges. So, two types of charges exist in nature. Named by Franklin as positive and negative. So in nature, two types of charges exist. Franklin named them as positive and negative. He said that charge on an electron is negative and charge on a proton we consider as positive. Now, one more thing. The scalar. What about the SI unit of charge?
Coulomb.
Yes. SI unit is Coulomb. What about CGS unit? SI unit is Coulomb, right? What about the CGS unit? CGS unit is it's stat Coulomb. You can even write this as stat Coulomb. Or the CGS unit is also known as electrostatic unit. Electrostatic unit. ESU. So SI unit is Coulomb, or its CGS unit is stat Coulomb or electrostatic unit, that you can write as ESU. Just note it down and let me know when you're done.
Okay.
For the first three classes, we will move very slowly, and after three classes, we will speed up our steps.
Okay, sir. Done, sir.
So the minimum charge, the next property is the minimum charge that can exist in nature. Minimum charge that can exist in nature is plus minus 1.6 into 10 raised to the power minus 19 coulomb. That is, or you can write this 1.6 into 10 raised to minus 19 coulomb as plus minus. This is the minimum value of charge that can exist in nature in free form. The minimum charge that can exist in nature in free form is this, plus minus. That is charge over an electron. That is charge on an electron or proton. So this is the minimum value of charge that can exist in nature in free form. A charge less than 1.6 into 10 raised to minus 19 cannot exist in nature in free form. And this E stands for 1.6 into 10 raised to the power minus 19. So whenever you have E in your syllabus, that E will stands for 1.6 into 10 raised to the power minus 19. The next is most of the objects So, Jumena, what about this pen? This pen is charged or neutral?
Charged.
This is charged. Why? Why? If it is charged, and if this remote is charged, then they should attract or repel each other.
Remote is charged.
If you're saying this pen is charged, I'm saying this remote is charged, then they should attract or repel each other.
If it's same charge, they will repel.
Yeah.
If it's opposite charge, they'll attract each other.
But they are neither attracting nor repelling. Like I've placed them in equilibrium. They are neither attracting or repelling each other.
So neutral.
Neutral. So what does neutral means? Neutral means it's chargeless, or it means that it have equal amount of positive and negative charge.
Equal amount of positive and negative.
So how that equal amount of charge is distributed? So that equal amount of charge is distributed over an electron or a proton. If you keep on dividing this pen, if you divide this pen, you will get compounds. If you further divide it, you will get molecule. If you further divide molecules, you will get atom, right?
Yes, sir.
What are the constituents of an atom?
Features of an atom.
Constituents. So if I further divide atoms into parts, what are the constituents of atom?
Substances.
If I divide atom into
Molecules.
No. What are subatomic particles? If I take an atom, I divide that atom into subatomic particles. So there are 3 subatomic particles, no? Electron and
proton, neutron.
These are 3 subatomic particles. So out of electron, proton, and neutron, all these 3 particles are charged, or any one of them is neutral?
Neutron is neutral.
So shall I say that neutron is neutral, or should I say that neutron is chargeless? There's a difference between chargeless and neutral.
Neutron is neutral.
Neutral means, if I'm saying that an object is neutral, that means that object have equal amount of negative and positive charge. But if I'm saying something is chargeless, that means it neither have negative or not positive charge. Neutron doesn't have further negative or positive charge. So your neutron is not neutral. Neutron doesn't have electron and proton. Neutron is not neutral. Neutron is basically chargeless. But electrons and protons have charge. So if you take an atom, like say, if I'm taking an atom, this atom will have nucleus. Nucleus will have positively charged protons. And around this nucleus, you have 2 electrons. I'm not considering neutrons because neutrons are chargeless. Neutrons doesn't have any charge. So Jumena, what's the net charge over this atom?
Total charge 0.
0. So can I say that this is neutral?
No.
Yeah. Neutral means a system have equal amount of positive and negative charge. So this atom have equal amount of positive and equal amount of negative charge. So you can say this is neutral, right?
Yes, sir.
So this atom is neutral. The net charge over the atom is 0. So you can say that most of. So what about this pen? This pen is charged or neutral?
Neutral.
Neutral. What does neutral means? Neutral means this have equal amount of electrons and equal amount of
Protons.
So most of the objects in nature are neutral. They have equal amount of positive and negative charge. So almost every object that you will consider in nature is neutral. Means it have equal amount of electrons and protons, it's neutral. So if an object is neutral, then will it experience electric force?
No.
An object will experience electric force only if it is charged up. So if you have two bodies which have positive charge, if you have two similarly charged bodies, if you have like charges will ripple and unlike charges will attract each other. So like charges will repel each other and unlike charges will attract each other. So these are few basic properties of charge. The next is charge. So if I consider an atom, this atom consists of a nucleus. This nucleus has some protons, and around this nucleus, 4 electrons are revolving. So electrons are revolving around the nucleus. So what about the net charge? Net positive charge. How much is net positive charge on this atom?
3.
Net positive charge. Plus
4. Yeah, plus 4.
charge on a proton is plus E, so that's plus 4E. What about the net negative charge?
Minus 4.
What about the net charge?
0.
Net charge is 0. So this atom is neutral, right?
Yes.
Okay, Jumena, just think, how can you charge this atom? If I ask you to make this atom positively charged, how can you make this atom positively charged?
Amount of neutrons like minus 3.
Minus 3, right? Means you are saying to decrease the number of electrons?
Yes.
Okay, so if I somehow remove one electron from this atom, if I remove one electron from this atom, so left with 3 electrons and number of protons are same as that of before. I haven't changed the number of protons. So what about the net charge now?
Plus E.
Very good. Plus 4E minus 3, it's plus E. So your atom is positive charge. So if you want to make an object positively charged, then it will lose electrons. A positively charged body will lose electrons.
Lose electron.
What about its mass? Positively charged body will lose electrons. What will be the effect on its mass as compared to neutral object? If it was neutral, its mass is say m1. I make this object atom positively charged, its mass is m2. Is m2 equal to m1 or m2 greater than m1 or m2 less than m1? Can you compare m1 and m2?
Yeah.
The mass will remain same. It will increase or decrease during
It will increase.
It will increase. Let's see. So this neutral atom have 4 protons and 4 electrons. So the mass of this atom is the mass of 4 proton and mass of 4 electron, right?
Yes, sir.
Now just count the number of electrons here.
4. No, 3.
So what about the mass of this atom now? The mass of this atom is mass of 4 protons,
3 electrons.
3 electrons. So what happened with the mass? It increases or decreases?
Decreases.
The positively charged body will lose electrons and its mass decreases. Just note it down.
Okay.
We will use these concepts in Coulomb's law. In some numerical of Coulomb's law, you will use this basic concept of charge.
Done, sir.
Okay, if I ask you to make this atom negatively charged, how will you make this atom negatively charged?
Reduce one proton.
Don't change the number of protons. This we will discuss in the next section, that we can't change the number of protons. We can play only with the number of electrons. So what would you do to make it negatively charged? Yes, Juban. We can't change the number of protons. Practically, we cannot
Add more electrons.
Yes, you can add more electrons. So this term have 4 electrons and 4 protons. Just add one single electron. So the net charge will be plus 4e minus 5e, so it's minus. So if you're saying a body is negatively charged, so a negatively charged body will gain electrons. What will happen to its mass?
It will increase.
Yes, it will increase. Its mass will increase. Sure. Just note it down.
Done, sir.
So next is the definition of charge. So if you want to charge a body, then you will either add electrons or you will remove the number of electrons. So body can be charged. A body can be charged by transfer or redistribution of electrons. A body can be charged by transfer or redistribution of electrons. This is how we charge the body. So we can charge a body by transfer or by redistribution of electrons. The example of transfer we did in the previous section, that transfer means either addition or removal electron. The redistribution we will do when we discuss induction, induced charge. That then we will see what is redistribution. So basically, to charge a body, you will just change the number of electrons in that body. Then we have methods of charge. To change the number of electrons, you can change the number of electrons by either of 3 methods. Either by, you can charge a body either by friction, or you can charge a body by conduction, or you can charge a body by induction. These are 3 methods of charge. So you can charge a body by friction or by conduction or by electron. These are 3 methods of charge. In all 3 methods, we will change the number of electrons. There is one important note, that during charging, we cannot transfer protons? It's a 2-marker question. If you check the previous year's questions of CBSE, you will get this question. During charging, we cannot transfer protons. So can you guess the reason why we can't change the number of protons during charging? We can add or remove an electron, but we cannot add or remove a proton. Make some guesses, Ivana.
It's fixed.
It's fixed. It's fixed by, when we say something is fixed in physics, if a body doesn't move, that means net force on the body is zero. If you're saying that proton is fixed, that means you're saying that these protons are bounded by some very, very strong forces, right?
Yes.
If I'm saying this, a window is fixed in a wall, that means that window is bounded by some very strong forces in the wall. So if you're saying that protons are fixed, that would mean that protons are bounded by very strong forces. So by the way, what's the name of the force by which protons are bounded in a nucleus?
Force from neutrons. Nucleus.
Yeah, in nucleus, protons are bounded by a force which is known as nuclear force. And nuclear force is the strongest force in nature. So within this nucleus, if I say nucleus, if you have, this is nucleus, okay? If you have 2 protons, then these 2 protons will attract each other by a very strong force, which is nuclear force. So these forces are bounded by very strong nuclear forces. So the reason, and these nuclear forces are the strongest force in nature. If you take these surrounding electrons, so can you just name the force with which electron and protons are bounded? Electron and nucleus are bounded?
Electrostatic.
Electric force, electrostatic force or electric force. Nuclear force, so electrons are bounded by electric force. Protons are bounded by nuclear force. Nuclear forces are 100 times stronger than electric force. So which one is the strongly bounded system? Either proton or electron?
Proton.
Proton. So it's tough to remove or add an electron from the nucleus. So the reason why we cannot transfer protons, the reason protons are bounded by strong nuclear force. They are bounded by very, very strong nuclear force. So we cannot add or remove a proton. But the force with which electrons are bounded are comparatively weak. As if we compare the force of electron and this nucleus, then electrons are bounded by a comparatively weak force. So we can easily add or remove an electron through these methods, either by friction or by conduction or by induction. But through these 3 methods, we cannot remove or add a proton. That's why when we say charging, we talk about electrons. We never talk about protons due to this nuclear force. So is it clear?
Yes,
Just
sir.
remember this question.
Okay.
Note it down.
So done.
Okay, the next topic should be, I should discuss these methods of charging, charging by friction, charging by conduction, and charging by induction. But these methods of charging are in your syllabus in 2 chapters. You will study just brief introduction of charging in chapter number 1. Then these methods of charging are in very much detail in chapter number 2. So usually I don't waste time in giving introduction in chapter 1. Otherwise I have to do a single topic 2 times. So I will discuss this method of charging in chapter number 2. After
Okay.
potential, we will do these methods of charging in much detail. If I
Okay, sir.
discuss it now, I can give only the introduction of these topics, but we can't discuss detail until we have completed. So we'll do these methods of charging in chapter number 2. After these methods of charging, the next topic is properties of charge. It is properties. So these are some very basic properties of charge. The first basic property is its additive nature of charge. The first one is additive nature of charge. So additive nature of charge means if you have an object and you keep on supplying charges on this object. You supplied a charge of +2 coulomb, then a charge of +2 coulomb, then a charge of -1 coulomb. Then the net charge on the body is algebraic sum of all charges, +2, +3, -1. So that's +4. So additive nature of charge says net charge on a body, net charge on body is algebraic sum of individual charges. So the net charge on the body is algebraic sum of individuals. That's the first property, which is additive nature of charge. After additive nature of charge, the next property is conservation of charge. Conservation of charge. So conservation of charge simply says if you have an isolated system or an isolated system. Okay. By isolated system, we mean a system which is free from all external influences. Free from all external influences means the system is not connected to any other object. This no charge can enter the system or can leave the system. Isolated means no charge can enter or leave a system. If you have a system where no charge can enter or leave, then that system is known as isolated system. For an isolated system, net charge remains conserved. Means charge can neither be created nor destroyed in an isolated system. Can neither be created nor destroyed. This conservation of charge is one of the strongest conservation law that we do in physics. One is conservation of energy, but conservation of energy shows violations. There are instances where energy is not conserved, it gets destroyed or it gets created. Then there is one you must have about conservation of mass. Conservation of mass do have violations. Mass can be destroyed or it can be created. But this conservation of energy, this conservation of charge doesn't have violation. You can never create or destroy a charge. Okay, have you heard about any example or any situation where conservation of energy violates? An example where you can say that energy is destroyed or it's being created?
When one bombarding of gold foil.
Bombarding gold foil. No, not in Rutherford experiment. No. You are close, but not. But Rutherford experiment is not an example. Have you heard about radioactivity?
Yes, sir.
In Rutherford experiment, when you are saying that you are bombarding something, you are bombarding basically alpha particles, and those alpha particles are coming from a radioactive source. In that radioactive source, energy is obtained from mass. You must have this in atomic bombs or nuclear bombs, the energy that you get are at the cost of mass. Like in a nuclear bomb, if you have a bomb uranium, say nuclear bomb which is using uranium, 2 kg. Through radioactive reactions, this 2 kg mass will convert it into energy. So this is what happens in nuclear power plant or nuclear reaction. The whole of mass get converted into energy. So you had a mass of 2 kg in initial stage. In the final stage, you doesn't have any mass. So final mass is 0. So that means mass is conserved or loss of mass?
Loss of mass.
What about energy? Energy is conserved or it's getting created?
Energy is conserved, created.
Energy is created. So that's violation of energy conservation as well as mass conservation. And the equation that govern this conversion of energy into mass or mass into energy is this: E is equal to mc square. This equation says if m amount of mass is lost, E amount of energy will get created. So this equation is basically violation of mass and energy. It says that energy could be converted into mass, mass could be converted into energy. But there is no violation of conservation of charge. Charge always remains conserved. Whether you have a chemical reaction or a nuclear reaction or a particle reaction, whatever be the type of reaction you take, your charge will always remain. That's conservation of charge. After conservation of charge, just note these 2 properties.
Did, sir.
Okay. Shall I rub it?
Okay.
The third one is, which is quantization of charge. Quantization. Have you heard about quantization?
No.
There was a topic in class 11, that's Bohr's model. You remember?
Yes, sir.
In Bohr's model, you must have done energy of hydrogen atom. The expression was minus 13.6 by n square electron. So there you must have heard about this term. That was quantization of energy. Anyways, in a very general term, quantization means something which have fixed values. Quantization means something which have fixed values. If I'm saying that charge is quantized, that means charge cannot have any random values. The values like charge of 1.6 coulomb or 1.7 coulomb or 1.8 coulomb, I cannot randomly provide any value to charge. The values that a charge can have are fixed. Say this example, I'm just writing the statement, then we will explain it. Quantization of charge. It says that all observable charges in nature are an integral multiple of E, that is 1.6 into 10 raised to the power minus 90. Let's see what this statement means. Let's start with this particular example. To understand quantization, let's start with this example. Say you have an atom, and this is the nucleus of atom. So nucleus of this atom, say you have 5 protons, and around these 5 photons, you have 5 electrons. So this object, this atom is neutral. This atom is neutral.
No.
See,
Yes, sir.
Okay, let's make this atom positively charged. How will you make this atom positively charged?
Reduce one proton.
Proton?
No,
Right?
electron. Reduce one electron.
So the okay, just provide the minimum positive. What will you do to make it, to provide it the minimum positive charge? You will remove minimum number of electrons. if you want to make this atom positively charged, and that charge should be minimum. So what will you do? You will remove the minimum number of electrons, and that
Yes.
minimum number of electron could be 1. Number of electron cannot be in fraction or decimal. The minimum
One
number of electron could be 1. If you remove 1 electron, then the charge will be plus E, right?
Yes.
Or E is 1.6 into 10 raised to the power minus 19. Okay, now I'm saying provide just higher negative charge. This plus E is the minimum. What's the next higher positive charge that you can provide to this atom?
Negative charge.
Positive charge. Next higher positive charge. The minimum is plus E. We have removed 1 electron. What's the next higher positive charge that you can provide to this atom?
Remove one more
1.
electron.
The charge would be plus 2E. If you multiply 2 with this E, 2 with plus 1.6, so this will be 3.2, right? 3.2
Yes.
into 10 raised to minus. What about the next higher?
Plus 3E.
If you multiply it by 1.6, then it would be
4.8.
4.8 into 10 raised to the power minus 9. Next higher?
4E.
4E, right? I can write this as N. So the minimum charge is this 1.6 into 10 raised to minus 19. The next is this 3.2 into 10 raised to minus 19. Now, is it possible that an atom have a charge of 2.3 into 10 raised to the power minus 19? Is it possible?
Yes.
Yes. See, is it possible to transfer 1.5 electrons, Jubaina?
No.
Because the number of electrons can never be in fractions, right? So the minimum number of electrons that you can transfer is 1, and corresponding to that 1 electron, this is the charge. The next higher that you can transfer is 2, and corresponding to that 2 is this. If I say this is the charge of an atom, the number of electron would be in between 1 and 2, right?
Yes.
So that means number of electron would be a whole number or a fraction?
Whole number.
Whole number. No. If I'm saying the object have this charge of 2.3,
And then it's fraction.
then it's fraction. Is it possible to have number of electrons in fractions? No.
No.
Electrons cannot exist in fractions, right? They will be in whole number only. So is it possible that an atom can have this much of positive charge? Is this charge possible? No.
Yes.
Yes. 2.3 into 10 raised to minus 19. Just this. If you are transferring 1 electron, then the charge is this. If you are transferring 2 electrons, then the charge is this. If I'm saying this is the charge of an atom, the number of electrons will be in between 1 and 2. Number of electrons would be in decimal. But number of electrons can never be in decimal. It will be a whole number only. So an object can never have this much of charge. After 1.6, the next possible value is 3.2. In between 1.6 and 3.2, if you're taking 2.3, then this 2.3 will mean that you are removing 1.2 or 1.3 electron, which is not at all possible. Are you getting me? No.
Yes, sir.
So this is quantization, that number of electron, the charge over an atom will have fixed values. It cannot have any arbitrary random value. Say in this next case, after 3.2, what's the next higher charge? 4.8. What were the number of electrons corresponding to this charge of 4.8 into 10 raised to minus 19?
3 electron.
3 electrons. If I'm saying an object have a charge of plus 4.1 into 10 raised to minus 19, is it possible?
No.
Why?
Because the charge will be only in all numbers. It can't be fractional numbers.
Charge or number of electrons?
Number of electrons.
Number of electrons. The number of electrons corresponding to this number could be in fractions. So number of electrons can never be in fractions, right? So this is what we mean by quantization of charge, that all observable charges are an integral multiple of it. Integral multi means n is either 1, 2, 3 and all. Means charge could be E or it could be 2E, it could be 3E, 4E, 5E. It can't be 1.5E or 2.5. This is what we mean by quantization. That all observable charges follow a definite pattern. You can't provide any arbitrary number. I cannot say that a charge on an atom is 4.5 into 10 raised to minus 19. If I say that charge is 4.5 into 10 raised to minus 19, that would mean the number of electrons are in fraction. But we can't transfer number of electrons in fractions. So all observable charges integral multiple of E, that's quantization. Okay, so that was about positive charge. What about negative charge, Vena? If I want to provide a minimum amount of negative charge to this atom,
We can add.
What number of electrons that you can add?
We can add 1 electron.
And what about the charge corresponding to that 1 electron?
Negative.
Minus E. So it would be this.
Minus.
What's the next higher number?
Minus 2.
Next higher?
Minus 3.
Next, plus minus. So both positive and negative charges are quantized. The reason for the quantization is, what's the cause of quantization? Only
Integral multiple.
Number of electrons can transfer. Number of electrons cannot be in fractions. It will always be in integer. Just note it down. Here n is number of electrons transferred.
Done, sir.
Okay, let's solve some numericals on quantization. Start with the basic one. Calculate number of electrons corresponding to plus 1 coulomb of charge. Just calculate the number of electrons corresponding to 1 coulomb. Simple on this particular equation. Like Q is equal to N. So you have Q, which is 1 coulomb. You have E, which is 1.6 into 10 raised to minus 19. Just calculate N, the value of N.
1.6 into 10 raised to minus 19.
No. N. Q is given. Na?
Okay.
You're supposed to calculate N. Q is 1, right? See, Q is 1. E is 1.6 into 10 raised to the power minus. Yes, good, right. So Q by E will be in. So this is 1 divided by 1.6 into 10 raised to the power minus 19 is this. Take this 10 raised to the power minus 19 to numerator. So this is 10 raised power 19 by 1.6 is in. 1 by 1.6 is 0.625 into 10 raised to the power 19 is in. 1 by 1.6 is 0.625. So that's 6.25 into 10 raised to the power 19. So 1 coulomb of charge have this much of electrons. So is it clear?
Yes, sir.
Are you
So
comfortable? Yes.
is it compulsory to write in the definite numbers?
Yeah. In your board's exams, there is weightage of writing the final result in up to second decimal place. Some 5%, 4% weightage of numerical questions having numerical values is for this last point. So always report your result up to 2 decimal places. In every numerical, 4 to 5% is reserved for this final result. So shall I rub it?
Okay, sir.
Even are you comfortable with mole concept? Remember mole concept in chemistry? That, okay, let's revise this, mole concept. I will use mole concept in next numerical. Number of moles, let's say you have it's just a revision of chemistry. Say you have some element or some compound of mass n, and its molar mass is capital. Is mass of material, the material of mass n, and capital M is its molar mass. Like if you have oxygen, O2, so its molar mass is 16. So this is molar mass is given. You're supposed to calculate number of moles. So number of moles are simply
Given by
right.
given.
Then the number of atoms or number of molecule or number of atom in 1 mole is Avogadro number, right? 6.023 into 10 raised power
20.
So this is mole concept in chemistry. To calculate number of moles, you divide mass by molar mass, and then to calculate the number of atoms or molecules, just multiply it with Avogadro number, which is 6.023 into 10 raised power 23. Just note it down.
Done, sir.
It's a small example of NCRT. NCRT is saying calculate number of moles in 1 cup. 1 cup means 250 gram of water. You don't not moles, calculate number of electrons. So to calculate number of electrons, first of all, you will need number of water molecules in 250 grams of water. First of all, we will calculate number of water molecules. Once you have number of water molecules, then you can easily calculate the number of electrons. Number of water molecules, this is first which we need. Jumena, just tell me, how would you calculate the number of water molecules in 250 gram water?
250 by molar mass of water.
Very good. So first of all, we will calculate number of moles, right? So number of moles would be 250 gram divided by molar mass of water, which is 18. That's the number of moles. What should be the next step?
Substituting this value in Q by E.
No.
Right.
Then next we'll calculate number of molecules, right? Using
Yes.
Avogadro number. 1 mole is 6.023 into 10 raised power 23. So this much of mole will be, let's use unitary, 250 by 80 multiplied by 6.023 into 10 raised power, right? Is it clear?
Yes, sir.
So then these are the number of molecules, water molecules, 250 by 18 into 6.023 into 10 raised power 20. Next, so let's calculate, say, take this as 6. This is 6 3s are 18. I'm just rounding it off to 6. So 6 3s are 18. 3 8s are 24. Then this is 10. 83.3 into 10 raised to the power 20. So the number of water molecules are 83.3 into 10 raised power 23. The next is number of electrons in one molecule, in one water molecule. What are the number of electrons in one molecule of water?
1.6 into 10 raised to minus 19.
Number of electrons. Water is H2O, right?
Yes.
So can you just count the number of electrons in one molecule of water?
Okay.
Just count the number of electrons in one molecule.
18.
How you count 18? Let's see.
Yeah.
Just count the number of electrons in hydrogen. Hydrogen have 1 electron.
So 2.
Hydrogen will have 2 electrons, right?
Yes.
And what is the number of electron in oxygen?
1. No, 8.
8. So the total number of electrons are
10. 10.
So the number of electrons in one molecule of H2O are 10. So what are the number of electrons in itne molecules, in this much molecules of water?
Multiplied 10 into 83.3.
Yes. Number of electrons in 250 gram water. I represent it by capital N. That's 83.3 into 10 raised power 23 multiplied by 10. So it comes out to be, it's 83.3 into 10 raised to the power 24, right? These are the number of electrons in 250 gram. Can you calculate negative charge? Javena, can you calculate the total negative charge? Yes. You have the number of electrons, huh? So just use this relation, Q is equal to any.
Okay.
If you have n electrons, then charge on 1 electron is E. So you can multiply, simply multiply it with E. So that will be 83.3 into 10 raised power 24 multiplied by charge on electron, which is 1.6 into 10 raised to the power minus 19 coulomb. So is it clear?
Yes, sir.
So this is how you will calculate the charge on the number of electrons or the number of protons if mass is given. This is a solid example of NCRT. If you have mass of an element or an atom or a molecule, then first calculate the number of moles, then number of molecules, and then the number of electrons, and then you will calculate the charge. Just note it down and tell me if you have any doubt in it.
Done, sir.
So let's stop here.
Okay.
Continue with Coulomb's law in the next class. So
Okay.
today I'm just having a 1.5 hour lecture. From
Okay.
class onwards, we'll make it 2 hours.
Okay, sir.
That is